is a transportation problem. Now, transportation problem deals with the transportation of a single product from end sources to end destinations. Now, from the book from which we are going to take up this topic, that is your MD Taha. The book is Completions Research. Now, our purpose is to minimize the cost of transportation when the single product is transported from end sources to end destination. Now, suppose if S1, S2, Sm are end sources with availabilities EIs, where I is from 1 to n. Suppose from these end sources you have to transport a single product to end destinations D1, D2, Dn are destinations where the material has to be transported. Then your destinations where your aircraft with requirements B1, B2, Bn. With requirements B1, B2, Bn. Then what is our purpose? We have to transport your material which is available at these end sources, and the quantity available at each source is given by A1, A2, An to these destinations B1, B2, Bn, and with requirements B1, B2, B. Now, if Xij is the amount of product to be transported from ith source to jth destination, and your Cij is the per unit cost of transporting product from ith source to jth destination. Then, mathematically, a transportation problem can be written as So we can represent a transportation problem mathematically as minimize z, where z is a function and it is equal to summation I is from 1 to n, double summation j is from 1 to n, Cij xij. Means if we take xij as the amount which has to be transported from ith source to j destination, and Cij is the per unit cost of transporting your product from ith source to j destination. This is your objective function. And our purpose is basically what? We have to minimize the cost of transportation. So transportation problem deals with the problem where we minimize the cost of transportation. Where we deal with the cost of transportation, and this is basically subject to the conditions, or we also call constraints, that is x I1 plus x I2 plus x in is equal to ai. I is from 1 to n, means x I1 is what? Amount which has to be transported from ith source to first destination. If we add all this, we'll get ai, amount available at ith source, and the total number of constraints are n in this case. Similarly, your n constraints are a1j, a and j is equal to bj, means your amount to be transported from first source to j destination up to nth source to j destination. It means that the requirement at jth destination can be written in this manner, and your j is from 1 to n, and as we are talking about the quantity, so your all xij should be greater than or equal to 0. We call it non-negativity restrictions. We call it non-negativity restrictions. And one condition which we have to see at the beginning of solving a transportation problem, which is very important. Whenever we solve a transportation problem, we have to verify that whether the condition given is satisfied or not. That condition is that your summation I is from 1 to n, ai should always be equal to summation j is from 1 to n b. That means the total material available at n sources should be equal to the total requirement of n destinations. So whenever we start solving a transportation problem, at the first step, what we do, we always verify that whether total availability is equal to total requirement or not. Then we go to next step. Now, how to solve a transportation problem? Now, to solve a transportation problem, what we do, we solve a transportation problem in various steps, and in your step 1 for solving a transportation problem is, first we have to write your problem in the form of m rows and n columns, where m rows will denote your sources, material available, and n columns will give you the. So the first step is find the initial basic visible solution. So our first step is to write your problem in the form of m rows and m columns, and then find out the initial basic feasible solution. And step 2 is to find whether the given initial basic feasible solution is optimal or not. If your given initial basic feasible solution, which we have found in the step 1, is optimal, we use a method for that. If it is optimal, then we stop there. So as we have got a solution which will minimize your cost of transporting the product from end sources to end destination. If it is not your optimal solution, then we further continue till we get your optimal solution. Now, step 1, how do we find out your initial basic feasible solution? We have various methods to find out the initial basic feasible solution. I'll tell you about two methods. Your two methods, there we can find initial basic feasible solution. Initial basic feasible solution can be obtained by either northwest rule, or we can also find the initial basic feasible solution by Vogel's approximation method. Until and unless it is given to us that by which method we have to find out the initial basic feasible solution, we always find out the initial basic feasible solution by Vogel's approximation method, because this method brings us more near to the optimal solution. More near to the optimal solution. So I'll take an example and I'll tell you how to find out the initial basic feasible solution with the help of northwest corner method or Vogel approximation method with the same example. Let me take an example. Suppose we have given a problem. Where we have given 4 sources and 3 destinations, and we have to find out the initial basic feasible solution. My problem is obtain an initial basic feasible solution to the given transportation problem. Now my transportation problem is now our 3 destinations are A, B and C, and my sources are D, E, F, G. Now the rows and columns corresponding to the per unit cost of transporting the material is given to us as 11, 13, 17, 14, 16, 18 14, 10, 21, 24, 13, and 10. So suppose I want to find out the initial basic physical solution of this transportation problem where availabilities at three uh, sources is 250, 300 and 400. These are the three sources. A, B and C are my sources and my destination are D, E, F, J. There are four destinations. There are four destinations. And the material product available at source A is 250 units, at source B is 300 units, and at source C is 400 units. Similarly, your requirements at various destinations are 200, 225, 275 and 250. Now this is what? Suppose we take 30. This is basically your per unit cost of transporting the product from source A to destination E. From source A to destination E. So similarly, other per unit costs are given to us where this cost is per unit cost of transporting the material from these three sources to these four destinations. Now, first thing that we have to see, मैंने बताया था आपको कि total availability should be equal to total requirement. If we see this total availability is 950. Total availability is, if we add the three, it is 950, and if we add your requirement, that is also 950. So our first condition is satisfied where the total material available at three sources is equal to the total requirement of four destinations. Now we'll go to our next step. We have to find out our initial basic physical solution by northwest corner rule, or we call it northwest corner method. North will, as the name suggests, what we'll do? We'll take the cell in the extreme position of northwest. That is our first cell. That is our first cell, and what we'll do? This is the material available at first source, is 250, and this is the requirement of first destination, that is 200. So we'll allocate minimum of 200 and 250 here. That is, we will allocate here amount of 200. It means that our requirement at destination 1 is completed and we are left with material. Here we are left with 15 minutes. So what we have to do in the northwest corner method, we take the cell at the extreme northwest and we allocate minimum of x11 is equal to minimum of A1 B1, where A1 denotes my availability at the first source and B1 denotes my requirement at the first source. Now, if B1 is greater than A1, यहाँ पे नहीं है, यहाँ पे B1 is less than, then we move vertically downward, and if B1 is less than A1, which is here the case, then move horizontally to the right. So here we can see that your V1 is less than A1. So we'll move to the right and we'll go to next step. Again, we'll find out minimum of 50 and 225. So minimum of 50 and 225 is 50. So we'll allocate 50 units here and your availability is exhausted and the requirement left here is 175. Again, in the same manner, what we'll do here, V1 was your this quantity was greater than this quantity, so we'll move vertically downward and we'll allocate in this cell minimum of 175 and 300. That is, we'll allocate 175 here. So requirement of destination 2 is complete, and we are left with 125 units here. Again, in the same manner, sitting in the same manner, we'll move to the right and we'll allocate minimum of 125 and 275. So we'll allocate 125 here. Availability at source 2 is complete and we are left with requirement of 150. Again, we'll move vertically downward. We'll allocate minimum of 400 and 150 and we'll get 150 units here. Requirement of third destination is complete and we are left with 250 units here at the third source. So what we'll do finally, we'll allocate a quantity of how many units here? 250, as both these are equal. So we'll allocate 250 units here. So your requirement and your availability both are exhausted. So this is how do we find out your initial basic feasible solution to the given transportation problem with the help of northwest corner method. With the help of northwest corner method. Again, now where the allocation is there, we have allocated this unit to these cells. Those cells are known as basic cells. Those cells are known as basic cells, and where there is no allocation, those cells are your non-basic cells. So for a transportation problem, your number of basic cells should always be m plus n minus 1. Whenever we find out the initial basic feasible solution, we have to see whether number of basic cells are m plus n minus 1 or not. Here we can see that your number of sources, which we call m, they are 3. Number of destinations are 4, n is equal to 4. 3 plus 4 minus 1 is 6. So number of basic cells, we can see that 1, 2, 3, 4, 5, 6. So in the initial basic feasible solution, what we have got? We have got your 6 basic cells. If your number of basic cells are less than m plus n minus 1, in that case, what we do? We allocate, we take some of the cells which are not basic and will make them basic by allocating the amount epsilon which tends to 0 to that cell, so that we can make your number of basic cells equal to m plus n minus 1. So here what we have done, we have found our initial basic feasible solution with the help of northwest corner method. Again, in the same problem, suppose we want to, or I'll take another problem where we want to find out the initial basic feasible solution with the help of Vogel's approximation method. I'll take another problem. That is, suppose Suppose we have a problem again. Suppose this is my problem where we have three sources and four destinations again with the availability and the requirements given at your source as well as your destinations. My problem is there are three sources. One, two, three, one, two. These are the three sources. One, two, and these are the four destinations. D1, D2, D3, D4. Again, per unit cost in each cell is given as 21, 16, 25, and 13, 17, 18, 14, 23, 32, 27, 18, 41. 11 is the material available at source 1. 13 is the material available at source 2. 19 is the material available at source 3. And requirement of destination is 6, 10, 12, 15. So again, what we have to do? We have to find out initial basic feasible solution and cost of transportation of materials from these three sources to and destinations. Again, here I will use your Google's approximation to find out the initial basic feasible solution. So, for Google's approximation method, what we do? For each row and each column, we find out the difference between the minimum and next to minimum cost. Minimum and next to minimum cost, so that this your minimum cost in this row is 13 and next to minimum cost is 16. So difference between the two is 3. Again, minimum cost in the second row is 14, next to minimum is 17. So your difference is 3 again. Again, your minimum cost is 18, next to minimum is 17. So the difference is what is the difference? 9. Again, in this column, minimum is 13, next to minimum is 23, difference is 10, minimum is 14, next to minimum is 18, difference is 4, 16, 18, difference is 2, 17, 21, difference is 4. So,